We're going to do an optimization problem. We're going to identify the absolute maximum and the absolute minimum of a function. Now we're going to do it with a graphing calculator because the problem that we're working with more or less requires a calculator, depending on how much time you have or your capability. But for this test, if you're doing the review or if you're going to take my test, then it's going to be a question where you're going to need a graphing calculator to be able to identify the absolute maximum and the absolute minimum. So why don't you get a graphing calculator right now, and or something like it. And here's what we're going to do. We're going to identify the absolute maximum and the absolute minimum of the function f of x equals x squared times sine of x plus 2. Okay? And the procedure for identifying the absolute maximum and the absolute minimum is the same no matter what you're doing, it in the sense that it's generally the same procedure. And I'm going to put that procedure over here. Now the specifics of the particular problem that you have may require you to get the information in different ways, but it's still generally the same procedure. The very first step is you want to identify the, I'm sorry, and I forgot that this is on the interval. We're identifying the absolute maximum and the absolute minimum of this function, f of x, on the interval from -3 to 6. So the closed interval, -3 up to 6. So these are x values, okay? So if you think of a graph, think -3 is over here and 6 is all the way over here. So this function starting at -3 and then going up until 6, that's the domain that we're going to be working with. Okay, or not domain, but that's the interval we're going to be working with on the domain of this function. So now the very first thing that you want to do is you want to identify the critical values. So identify the critical values or the critical points, okay, or the critical numbers of f of x on the interval from -3 to 6. And this is just a fancy way, critical points, critical values, it's just a fancy way of saying the zeros of the derivative. Okay, so we need the zeros of the derivative. Well, to find the zeros of the derivative here, we would need the derivative. So the derivative, f prime of x, is going to require the product rule because this is a product of two functions. So we're going to do the derivative of this, which is 2x times that, sine of x, plus this, x squared, times the derivative of that. Derivative of sine of x is cosine of x. And then we're done with the derivative of this part, and then plus 2. So now we need the derivative of 2, which is, it's a constant, so its derivative is 0, so it goes away. So here's our derivative right here. So this, what we're going to do is we are going to plug this into the calculator under y1. So you're going to hit y equals, and where it says y1, you're going to type in 2x sine of x, and then close the parenthesis, plus x squared, and then times cosine of x, and then close the parenthesis. And now you're probably going to you could hit zoom 6, you could just hit the graph button. There's lots of ways of seeing the graph. Mainly you hit the graph button, but if you can't really see your function, you want to hit zoom 6. But then if you still can't see it, you may want to move the windows around. Okay? Now I'm actually, because this says from -3 to 6, I'm actually going to hit the window button, and where it says x min, I'm going to put in -3, and where it says x max, I'm going to put in 6. Then I'm going to hit graph, and it's only going to show me the derivative, it's only going to show me this between -3 and 6. And if I look at that, I can see that there are 1, 2, 3, 4 zeros. So there's 4 zeros on the derivative from -3 to 6. And since I want to know where this is equal to 0, that gives me the critical points, the zeros of the derivative. I want to find those 4 zeros. Now one of them looks like it's at 0, at x equals 0. So meaning y equals 0 when x equals 0. So I'm going to find out. I'm going to hit the trace button. Trace allows me to put an x in, and it'll tell me what the y value is. So I'm going to put in 0 as the x value, and I'm going to press enter. So I hit trace and then 0 and then enter, and sure enough it says y equals 0. That means that's one of my zeros. The zeros of a derivative aren't where x equals 0, it's where y equals 0. We want to know what x values will make the output of this equal 0. Okay? And then what I'm going to do is I'm going to create, well actually I don't need to do that, sorry. I just want to identify the zeros. So I know that one of the zeros is at x equals 0. Well, there's 3 more. To find out where those are, I'm going to use the 0 feature of the calculator. I'm going to press in the graph screen, I'm going to press second, then the trace button, which gives me the calculate menu. Option 2 says 0, and then it says left bound. That means it wants an x value that is left of the 0 you're looking for. Well, if you look on here, it looks like there's a 0 just beyond -2. So kind of between -3 and -2. So on the left side of that is -3. So I'm going to key in -3, enter. Then it says right bound. It now wants an x value on the right side of the 0 that you're looking for, and -2 is on the other side. So I'm going to key in -2, enter, and then it says guess. Guess means give them a number that's close to the 0 so it knows where to look. I can move the little cursor close to the y-intercept, or excuse me, the x-intercept, and press enter or move the cursor on the graph near the x-intercept, near where it crosses the graph crosses the x-axis, which is the 0. Press enter, and it says I have a 0 at -2.2889. So I'm going to write that up here. X equals -2.889. Okay? Now I'm going to do the same thing for this next 0 right here. I'm going to go second, trace, option 2, left bound. Well, this one's sort of between 2 and 3. So left bound is 2, enter. Right bound is 3, enter. And then guess, I'll just press enter, and it says there's a 0 at +2.2889. So x equals 2.2889. And I only have one more 0 to get, and that's all the way over here. It's right around, let's see, 6, 4, 5, it's right around 5. So I'm going to hit second, trace, option 2, left bound. I'm going to put 4 in, because I don't know which side of 5 this is on. It might be right at 5, but I doubt it. I'm going to hit left bound 4, right bound 6, guess. I'm just going to press enter, and it says that there's a 0 at 5.0869. So x equals 5.0869. Now the problem you work on may only have 2 zeros or 3 zeros or something like that. Okay. Now that's step 1. We've identified all the critical points, all the zeros of the derivative. Step 2 is list the critical values, which you just found, and the end points. These are the end points. This is the left end, that's the right end. And the critical values and the end points are all of my candidates as candidates. These are my candidates for absolute maximum and absolute minimum. And I want to list them all in a table. So I'm going to make a table here, and I'm going to list all of these numbers. I'm going to put x equals and I'm going to start with -3. I have 1, 2, 3, 4, 5, 6 possibilities here. So I need to make room in my table for 6 possibilities. These are 6 possibilities for the maximum and minimum. I've got -3, then I've got -2.2889, then I have 0, then I have 2.2889, then I have 5.0869, and lastly I have 6. These are all, I have my endpoints and all my critical values in the table. Okay? All right, list critical values and endpoints as candidates in a table. Well, it's kind of second to last step. Step 3 here, plug all of those x values in step 2 into the original function, f of x, into f of x, because we don't want the maximums and minimums of f prime. If you plug these numbers into f prime, you will get 0. How do I know you're going to get 0? Because they're the zeros of the derivative. So if you plug these in, you'll get 0. So if you start getting 0 for all of these, or something close to 0, you know you did something wrong. You need to be plugging these numbers into the original function. So here's what I'm going to do. I'm going to key in. So these are my f of x values. So f of x equals, I'm going to plug -3 into this thing here. Okay? So -3 squared, and I'm going to put the -3 in parentheses. So -3 squared times sine of -3. Okay? Plus 2. Enter. And it says that the answer is 0.7299. 0.7299. Done. Next one. I'm going to plug this one in to here. Okay? So I'm going to go -2.2889 squared times sine of -2.2889 plus 2. Press enter, and I get -1.9453. -1.9453. Now, I'm going to plug 0 into this. So I get 0 squared, which is 0, times sine of 0. Now 0 times anything is going to be 0. So I already know that this is going to be 0, and then plus 2 is 2. So I'm going to put a 2 right here. But you can plug it in your calculator and you'd still get 2. Now I'm going to plug 2.2889 into here. All right? So I'm going to plug in 2.2889 squared times sine of 2.2889 plus 2 gives me 5.9453. 5.9453. Now I'm going to plug in 5.0869. So I'm going to put in 5.0869 squared. 0.869 squared times sine of 5.0869 plus 2. And I get -22.0829. Lastly, I'm going to plug 6 in here. So I'm going to do 6 squared times sine of 6 plus 2 press enter, and I get negative 8.0589. 0589. Now you have to show all of this work on your paper. I don't want to just see the question and the answer. You got to show this work. You have to show that you know how to identify the zeros of the derivative, how to plug those numbers in. This table is essential. And the last step, step 4, is identify the highest output value and the lowest output value. Those are the absolute maximum and the absolute minimum. Well, if you look at these 6 output numbers, which of them is the highest number? 5.9453. That is your absolute maximum on this interval. No other number is going to be higher than that. And we know it's the highest because the zeros of the derivative indicate all of the high points and low points on the graph. And the endpoints aren't any higher than this, so that is the absolute maximum. So I would say absolute maximum at, and I'll say f of 2.2889. 2.2889 equals 5.9453. 5.9453. That's what you will write on your paper. You'll write absolute maximum at f of whatever the x value is equal to whatever the high point is. Now, what's the lowest number? We're usually looking for the largest magnitude negative value. But if there are no negative values, then you're just looking for the lowest number. In this case, we've got negative 22. That is the lowest number of all these output values. So the absolute maximum is at this x value with that output value. So the absolute minimum, I don't know if I just said maximum, I meant absolute minimum, is at f of 5.0869, 5.0869, and it's going to be equal to negative 22.0829. There we go. And that is how you do an optimization problem, to identify the absolute maximum and the absolute minimum. Okay?